From a topless drive, allowing us to see the moving parts of a typical disk drive, we're playing a sequence of properly recorded files. Notice the output in the application shows 50 plus megabytes per second. Also note that the drive head does not appear to move much, if at all. This indicates the data is properly recorded to minimize head seeks, thus minimizing latency and maximizing performance. From the same topless drive, we're now playing improperly recorded files. Notice the output from the application has dropped from 50 megabytes per second to less than 15 megabytes per second, indicating considerable data randomization. Also note that the disk head is now active, swinging back and forth between disk tracks as it seeks to gather up the randomized data. The critical fact to keep in mind is that whenever the head is in motion, I/O essentially comes to a halt. Even after the head is repositioned, it may have to wait nearly a full disk rotation for the desired data block to be in position for reading. Next, we play the same improperly recorded files as before from a second window to emulate dual stream concurrency. Notice how the speed has dropped from nearly 15 megabytes per second in example 2 to well under 2 megabytes per second in both windows. This clearly shows that the file randomization causes the total output to drop by 87% compared to the single stream in example 2. Compared to example 1, with the properly recorded files, the output even dropped by 95%. And notice the disk head is now practically a blur as it rapidly seeks to gather up the data. The percentage of time it spends at rest when it can actually read the data is now extremely limited. While the disk head is in motion, every other component in the system is sitting idle, waiting for its I/O request to complete. These examples visibly demonstrate how improper data recording can have a devastating effect on streaming performance.